In 1801, a physicist named Thomas Young fired light through two narrow slits and accidentally broke our understanding of reality. What he saw on the screen behind those slits should not have been possible. It defied every law of physics that existed at the time. Scientists have been repeating this experiment ever since, trying to understand what it means. And in 2025, MIT ran the cleanest version of it yet. The result was the same. It is always the same. And what it tells us about the nature of reality is either the most profound discovery in the history of science or the most terrifying. Possibly both. Here's the setup. You fire particles, electrons, photons, even atoms, through a barrier with two narrow slits. Behind the barrier is a screen that records where each particle lands. Now, if particles behave like tiny bullets, you'd expect two clusters on the screen, one behind each slit. That's what common sense says should happen. But that is not what happens. Instead, you get an interference pattern, alternating bands of light and dark, like ripples in water overlapping each other. The particle isn't going through one slit, it's going through both, simultaneously, as a wave of probability interfering with itself. A single particle, two slits, both at once. That is not supposed to be possible. And it gets stranger. Scientists decided to find out which slit the particle actually went through. They placed a detector at the slits, just to watch, just to measure. And the moment they did, the interference pattern disappeared. The particle stopped behaving like a wave and started behaving like a bullet. Two clusters, exactly where common sense said they should be. The act of observing changed the outcome. The particle seemed to know it was being watched, and when it knew, it chose. Not randomly, but differently. The question that has haunted physics ever since is this: does reality only become real when something looks at it? Is the universe only rendering what is being observed? This is not a metaphor. This is not philosophy dressed up as physics. This is the mathematical foundation of quantum mechanics, one of the most precisely tested theories in the history of science. Before measurement, a particle exists as a wave function, a cloud of probabilities. It is not in one place. It is in all possible places simultaneously, with different probabilities assigned to each. The moment you measure it, the wave function collapses. The probability cloud snaps to a single point, a single reality. Richard Feynman, one of the greatest physicists who ever lived, said that nobody understands quantum mechanics, not because the maths doesn't work, it works perfectly, but because what it describes is a universe that does not exist in a definite state until something forces it to. Now, here is where it gets philosophically explosive. If you were designing a simulation of a universe, you would face an immediate problem. Simulating everything, everywhere, at all times, would require infinite processing power. So what would you do? You would only render what is being observed. Everything else stays as potential, as probability, until something looks at it. And that is exactly what quantum mechanics describes. Reality doesn't exist in a definite state until it is measured. The wave function is the unrendered state. Observation is the render trigger. John Wheeler, one of the 20th century's greatest physicists, called this the participatory universe. The universe only exists because we observe it. You aren't just watching reality, you may be creating it. In July 2025, MIT scientists ran what physicists described as the cleanest version of the double-slit experiment ever performed. Using ultra-cold atoms trapped in an optical lattice, they stripped the experiment down to its absolute quantum essentials. The result held. The interference pattern appeared when unobserved, collapsed when measured, perfectly, every time. The researchers noted that 2025 was declared by the United Nations as the International Year of Quantum Science and Technology, celebrating 100 years of quantum mechanics, 100 years of the same result. 100 years of the same unanswered question. What is reality when nobody is looking? There are several ways to interpret what the double-slit experiment tells us. The Copenhagen interpretation says the wave function simply collapses when measured. Don't ask what it means, just use the maths. The many worlds interpretation says every possible outcome actually happens, splitting reality into parallel branches with every observation. And the simulation hypothesis says the most economical explanation is that we live in a computed reality, one that only renders what is needed. None of these interpretations has been proven. None has been disproven. What we know for certain is this: reality, at its most fundamental level, does not behave the way we experience it. The solid, definite, always existing world we live in is built on a foundation of probability, uncertainty, and observation. That is not a small thing. Quantum science is accelerating. Quantum computers are being built on the very principles the double-slit experiment revealed. Quantum encryption is being deployed in communications networks, and the philosophical questions the experiment raises are being taken more seriously than ever before by mainstream physicists. We may never know whether we live in a simulation, but we do know this: the universe behaves as though it is hiding something, as though it has a rule that says reality only fully exists when something is there to witness it. You are witnessing this right now, which means, right now, you are making it real. If this made you question everything you thought you knew about reality, you're in exactly the right place. We cover the most mind-bending science and ideas on Earth every single week. Hit subscribe and turn on notifications, and we'll see you in the next one.